Okay, so it's basically here are the notes, and then I'm gonna, read through them and tell you the parts you need to do, and just tell you some things like I did say yesterday. I'll show you another boring video, right? But actually, it's a good video of it looks like a college professor that JB Statistics. What he must be his name, JB. I'm not really sure what that is, but just to give you some clarity on some of the stuff we're doing, I didn't really find anything yet today that wasn't a little too abstract. So, like, if I were to show you something today, it would, I don't think it would help in getting a firmer understanding. So, today is another wax on, wax off, and a lot of stuff will be coming out of left field. And you're just going to be asked to maybe um, just follow the schematics of how to do this. I don't like doing that as a teacher, but it was hard for me to find something that was good per se for what I wanted to be able to have you feel good, and me, being the first time I'm teaching this. So um, just leave it at that. There was a couple other things I've said throughout the other class. I can't really think. Maybe they'll just pop in my head as we go. But okay, but I do like that one video I showed yesterday at the end talking about the candy bar, because I think that's really the most powerful example of testing as a company, what they're putting on their package. Is it right? Let's say, is it valid? All right, so back to that. Confidence intervals are in relation to this level of significance about a population parameter being truthful or not, is what we're trying to actually emulate or test, I guess. So back to that candy bar, they say they should be 58 grams. That's their what they say about their total population mean total of grams. Now, if we get 1,000 of those candy bars and we find out that that mean of those 1,000 candy bars is 57 grams, does that say that they're lying? Well, is that significant enough to say that they are? And I think that was a good point with the guy with the cards. He gets 28 out of 100 suits right. Is that significant enough to say that he's special? I think you would understand if you did 1,000 candy bars and you saw the mean grams to be 50. Then through math, you probably find out that that is a significant difference, and therefore that company may be lying to us. So that's the idea. Just because 1,000 candy bars is 57 grams for a average amount of grams doesn't mean the company's lying. It's a ballpark figure, and there's levels of significance to find out if that's actually happening. So again, I'm just talking to kind of get you to feel the feel of what's actually happening here. All right, so what do you have to be worried about? The level of significance is denoted by I almost said sigma. That's alpha. Whew, had a little brain block there. So again, not formula, symbol recognition. We have to recognize alpha as the level of significance. And then these are just three common levels of significance that are used, and they are 100% tied to our confidence intervals that we used and did before spring break. And why do I have 3 stars by 0.05? Well, the answer to that question is, what was our most common confidence interval that we used out of these 3? Or which one did we say was the one most often used? And it was 95%. So therefore, the most common level of significance we're going to use is 0.05, which is completely and totally related to those confidence intervals. And hopefully we see that connection at least by Tuesday next week. Next 3 days, Wednesday, Thursday, and then coming back Tuesday, we'll put two more things that we're going to do together, Tuesday being a review. And then maybe at that point show a video after we do some of our wax on, wax offs. Maybe have something that can tie it all in together. It might be Tuesday, it might be something good to come back to. Or maybe tomorrow or Thursday. One of the 3 days I'd like to be able to do that. But I got to find one that really does a good job pertaining to what we're doing in class. Okay. So again, hopefully you can do that leap for me because I don't like, doing that to you. Oh no, I did too many things. Oh, hopefully it has the memory to do this because I can't write. I just found out. Go ahead and write this next part and you'll hear me complain. This is the first math class, and you probably agree with this too. You have to do so much writing of sentences. And I find when I'm taking the notes or writing notes for you, I can't stand doing it. So I think next year I'm just making PowerPoints and these, pre-written stuff's going to fly through or I'm going to type it. So that's why I just appeared my writing from, actually I did this 4th hour. Me talking out loud. So remember a parameter, and remember this is more for the next 2 days, not today. But we are going to identify some numbers and then use them pertaining to what we did before spring break. Parameter mu is a mean, an average of the population, and then from that you get a sample. This is like, again, the candy bars. They say it's 58 grams. Well, then I test 1,000 of them, and I find the mean grams of that. That would be X bar. And then we're going to have two different types of, this is related to what we did before break. Remember z-test and t-test, z-chart, t-chart, remember? Okay, when the distribution is normal, which is all that we've been dealing with, and somehow, some way the standard deviation is known, you'll use a z-test. The second one is when it's not known, that's the t-test. This is stuff you've already done. Now I know some did well on it, some struggled. May come back a little bit and hopefully we understand a little bit better. Then the last thing, P stands for what? Remember the confidence intervals that we did last? Proportion ones. P hat was the proportion you found of people doing a certain thing, whatever that may be. And that was always a z-test no matter what. Okay? So again, this is more so for the next 2 days. So remember this little stuff in the middle, or we'll come back to it and remind you. And then remember what a p-value is, which p stands for probability. P-value is the area under the curve at a certain position, wherever we're looking at, which we'll look at. And that's a probability. That area represents a probability. What we're trying to emulate is the probability of obtaining a sample results, a result from a sample, with a value as extreme. That means right around, and it actually is pretty much in line with the population parameter that's thrown out there. Or is it more extreme than the population parameter? That's what we're trying to do. So again, back to the 58 grams. If our sample is kind of small and we get 57 grams, that's probably not a significant enough difference to say that this company's lying. But if we have a bigger sample size, and that bigger sample size has a mean grams of 50, then that's probably significant enough to say that that company is a liar and they're in trouble. So that's what this little sentence maybe means with that one question we had back in the day. And then it's dependent upon the type of test, which is what the next part I'll reveal will be. Wax on? What? Okay, so again, just the informant, and I need some clarity on this as well, but let's just all jump in on this together, that there's 3 categories of tests, and it's based off of the alternative hypothesis statement. And that's what you went through yesterday. You know, what's the null hypothesis? What's the alternative hypothesis? What's wrong? Was something funny? Okay. Yeah. All right. So here are the 3 things that we need to be aware of. And I think, okay, again, wax on, wax off. But I think this is easy to understand what type of test it is. So there's a second thing that we have to be aware of. Is it a left-tailed, a right-tailed, or a two-tailed? And it really depends upon what H of A is stated as. So if the alternative hypothesis contains less than, which that's the only one to put in parentheses, that means the alternative hypothesis is stated to be less than whatever the variable is, mu, standard deviation, or p, is less than a number, then it's a left-tailed test. What's so simple about this is what kind of numbers are left on the number line? They're over here, right? So less than, that's what I meant to say, less than are numbers left on the number line. So it's left on the standard normal curve is where that shaded region would be. In a right-tailed test, again, we have to memorize that it's the alternative hypothesis, what that is. If that contains greater than, numbers that are greater than are right on the number line. So it's a right-tailed test. And then not equal to is the two-tailed test, where that's, you remember when we said a 95% confidence interval? That's actually how that graph looked. 95% of the data was in the middle. Then the rest of the 5% was on the two tails. That happens on a not equal to situation when H of A is not equal to. Oh, I hope this all keeps going the way I'm doing this. My writing already done, and yeah. All right, anyway. And then the third thing you have to do today is make a decision. And this is where I hope I give you clarity, and myself, by the way. All right, it should make sense. I kind of read some things, but I'm just not ready to tell you why. Then you make a decision on the p-value. This is the beginning of the mathematical way of saying, all right, let's go back to that 58 grams. What you find in the sample, is it significant enough to say that that company's a liar? That from this sample, there is such a significant difference below 58s that they're lying. And then this is the math involved. So what you have to do is compare the probability, P, to the level of significance that you chose to use. And if P is less than alpha, you will reject, sorry, very tough for me to say, the null hypothesis. So the null hypothesis from yesterday was that's 58 grams. All right. Well, we reject that because there's a significant evidence to show that from the sample, it doesn't show that. Or the opposite of that is if P is greater than or equal to the level of significance alpha, you fail to reject the null hypothesis. So you failed to show that the company is lying. So what it does is verifies that population parameter from your sample seems to be okay at this level of significance. You can write this down or not. This is basically what I just said there. What does it mean when you reject the null hypothesis? That means for H, the null hypothesis, there's not sufficient evidence enough to verify that this is truthful about 58 grams. So that means we're saying that there's a problem in that particular case. Now these change depending on the scenario. So if you reject H sub O, then that means there is sufficient evidence for the complement of that. There is sufficient evidence that the amount of grams in the candy bars is not making it to 58 and you're cheating the customer. So we do understand what it means to fail to reject. I guess this is just a terminology, because that what you're trying to do, I guess, trying to test this company. So you failed to reject the null hypothesis. So that means there is sufficient evidence to support it. There is not sufficient enough evidence against it. In that particular, specific example, just trying to give you a feel for what's being said. All right, I hope you wrote all that and all my storytelling. How's that come? Good? All right. Okay, so as hopefully things keep flying in here, you wrote this down, and then pause if you feel like I'm going too fast and read the question. Okay, do get ready to identify these, although just understand that all the variables are given for you to write your sentence. And then as we go further, we may complicate things a step at a time. So number one, What is salary is larger than 48,000? What is that actually? What variable is that? So that's what we have to do. We have to identify variables. Okay, it's mu, but which one is it? Is it the null hypothesis or the alternative hypothesis? Alternative hypothesis. So that is the first thing. It doesn't necessarily have to be, but it probably should be the first thing that we write down. It is an average, so it's mu that they're saying. And because it doesn't have an equal sign in it, that's the alternative hypothesis. And then what's over here that nobody writes except one student who got a 5 out of 3? What's this? The sentences. And I said, oh, you bums aren't going to write those, so. And I guess it is kind of redundant. But I will demand one other sentence at the end of this, your conclusion. And then just for giggles, to remember what we did before break, we do have a sample size. And from that sample size, we do have an average salary from that sample size. And the way this is worded, last hour actually did a good job about asking this as well. What is the standard deviation? Well, the way this is worded, it's from the sample. Just read that sentence. So, oh, shucks. I forgot to ask, is this a right-tailed or a left-tailed? What is it? Right-tailed, but why is it a right-tailed? Because the alternative hypothesis is what? Greater than, if we were to draw this out, to be shaded on the right. But these are things that we did before break. The sample size is 500. The sample mean is 51,200. And the sample standard deviation, that's why I stopped and read that. And, someone had a great question last hour to kind of get through that, is 1,500. Okay, and then I think I got this right. No, too much. Okay, so we give you the p-value, and we ask what the level of significance. So we want a 5. Remember I said 5% is the most or more popular because 95% confidence intervals were the most popular confidence intervals used. So we have everything that we need. This is possibly for later, but just to remember, what those variables were. They're not really needed in this because we give you p. Just went ahead and give it to you, so you just get what you have to do schematically for these things. So the level of significance is 0.05, and the probability value for this situation is 0.0166. So this is what you need to write, and this is what is demanded. Since, maybe you don't have to restate the numbers, you could say since p is less than alpha, since p is less than alpha, we reject h sub 0, or the null hypothesis. That means there is sufficient evidence to indicate that the average salary 3 years after graduation is greater than 48,000, because we reject this hypothesis, which should make sense to you. But now we got some numbers tied into it, as opposed to just saying, like yesterday, 58 grams, I got 1,000 candy bars, and I get 56 grams. Well, that company's a bunch of liars. Well, that may not be significant enough a difference, depending upon how many bars you tested comparative to how far they are away from each other as well. And that's kind of what I want to get you a feel for. Now, as you write this down, what might you still say is problematic with this study? I see one glaring weakness with this study. And this could go back to previous chapters of, what could be wrong with studies. I want you to think about that as you're writing, and then someone raises their hand. So the first thing I thought about is this. The Department of Education doesn't always worry about Harvard, only worry about Harvard. It worries about all the graduates. So if you take a study from just Harvard students in general make more money when they come out of college. It's just a natural progression of things, as opposed to bigger state schools that, I don't know. Just, that, right? So we could say that this study is not really valid because you didn't really have a valid sample, not just the size of it, where you took it from. A more valid sample would be randomly selecting numerous students from numerous colleges that represent, all colleges throughout the nation. So blah blah blah. And that goes back to valid samples taken that we've actually talked about in previous random sampling and blah 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 blah. So that was, I thought, the most glaring weakness of this. Just something to think about.